Hello guys, and welcome to KED Academy. So for those who are still new here, please you can consider subscribing, and for those who are coming back, welcome. So in today's video we are going to be looking at the qualitative analysis. So I did a video yesterday on qualitative analysis, so if you haven't checked that out, the video of yesterday is necessary for the one of today. So I'll put a link up in the video. You can also click and watch. So we know that in most experiments are done theoretically in many schools here in Cameroon. So what I do is that when I was still writing my own GCE A levels, I usually go and watch online videos. So there are tons of videos on the YouTube online, but now it is very difficult to know which one exactly will come for the GCE practicals. So after watching many videos, I've gained experience, and I am at the position that I can predict, or I can know which of those experiments will likely come, and even if it doesn't come, what they're going to do in that experiment will be similar to what might be required of you. So the thing is that the GC, you can actually have an A grade. You can actually have a very good grade in the practical sessions, because all instructions will be given to you, like everything will be given to you, and you have to take note whenever you are asked to use a reagent in excess. Always make sure to use a reagent in excess, because if you use it if you use it in a limited amount, it's going to give you a different result. So while you are in the laboratory, always make sure you follow those instructions strictly. So as I said, I've done two videos. You have to, if you have to watch the one of yesterday before you can be able to get a very good knowledge of this one. And not all the experiments that are done in this video are going to be done on the examination day, because some of them are costly. You know, the GC board is out to make money too, so they cannot do some certain experiments, but just the procedures of doing it, it might help you in following the instructions that might be given. So in the laboratory, it's a very normal activity. Don't feel panic in the lab. Just follow the instructions carefully. Wear your goggles, if possible. Wear your gloves, your face masks, and I think you'll be good to go. So in this video, in this particular video, we are going to look at qualitative analysis of cations, and using sodium hydroxide. I know when you are testing for cation, we use sodium hydroxide and we add it drop wise. So, and we're also going to be identifying crystals or salt, and we'll do pH paper test. We know that you have to dip a pH paper in this one will likely come. You dip a pH paper in a solution, you look at the color, you compare with your pH meter or the paper that will be given to you to compare the colors. From there, you know if it's an acid or a base. If it is red, you know that's an acid. If it is it blue, or you know that's a base. So you have to be very careful when it comes to that. So my advice before you watching this video is that you take a note paper, you will jot down some important points. You have to jot things down, jot the important things down, especially for the first part of the video. And also take note when the instructions mention an excess of reagent. I want to emphasize on this point, because when I was doing my own experiment, I think this part also came, and many people fail because they didn't add excess of it. So please always make sure to follow instructions. It's very easy, it's very normal. So okay, let's get into the video.
Okay, in today's experiment, we are going to do an analysis, a qualitative analysis for the cations. Anytime I have a cation solution, it is the best way to identify them is to add sodium hydroxide drops. Some of the cations will not form a precipitate, so we will identify those cations by doing the flame test. Other cations will form white precipitate or a colored precipitate. So what we're going to do right now, I'm going to take a cation sample from a different cation every time, and I will add to it sodium hydroxide. So first, let us begin with lithium cation. So here, this is lithium cation. Adding to it drops of sodium hydroxide. Nothing will happen. Okay. Now, let's try with the potassium. This is potassium. This is a sample containing potassium ions. We add to it drops of sodium hydroxide. Again, no precipitate. Now we will try the sodium cation. With the hydroxide solution, no precipitate. Let's try calcium. This is calcium with the hydroxide, a white precipitate. So we will do another test for this to identify the calcium. Let's take the magnesium. This is magnesium, and this is hydroxide. Okay, now if I compare the calcium and the magnesium is brighter. The magnesium makes a gelatin white precipitate. Let's try now the barium. This is barium solution. This is not a precipitate, but the solution turns cloudy. Okay, now the aluminium. This is aluminium solution with the sodium hydroxide. It's a white precipitate, but if I put excess sodium hydroxide, it redissolves again. So we're gonna put it with the white precipitate if we're adding drops, and then we'll differentiate it from the others by adding excess sodium hydroxide. Now let us try the lead. Let's start with the transition metals. A solution of lead nitrate. So with a sodium hydroxide, also it gives a white color. So here, this is the other white color we have. So we need to do some more tests to differentiate between lead and calcium. Now let's try this with iron. Cleaning this. Okay, a solution of iron 2, Fe plus 2. This is iron 2 solution with the sodium hydroxide, drops of sodium hydroxide. It's green. Whereas the iron 3, it's a brown color. Let's see the iron 3. Now you will notice that already the brown 3 has a color. The iron 3 has a color, but this color changes if I put sodium hydroxide. It becomes dark brown precipitate. So this is iron 3 and this is iron 2. Iron 2, iron 3. Now let's try the copper. The copper is a blue solution. It's a blue solution, copper 2. Upon adding sodium hydroxide, it will give a blue precipitate. Now the zinc. Let's just clean it. This is a solution of zinc. Let's put some more zinc. And with sodium hydroxide, it forms a white precipitate, but with excess sodium hydroxide, this white precipitate redissolves. I can repeat this slowly to show you the white precipitate. This is zinc, and I will add a few drops of sodium hydroxide. You see, this is a white precipitate. Now if I add more, it will redissolve. Now we will try the silver. Solution of silver. This is silver, and we add to it sodium hydroxide. It turns brown to gray. And finally, trying a cobalt solution. The cobalt already has a red, dark red color. So if I add to it sodium hydroxide, the color turns blue precipitate. I get a dark blue precipitate.
Alright, so I found these crystals at the bottom of this flask, and I have no idea what they are. So today we are going to attempt to figure out what they are. That's kind of what it looks like. They were like typical crystal structure. So I really have no idea what these could be. I want to attempt to figure out what it could be. My current hypothesis is that these are potassium carbonate crystals. Not 100% sure, but the last video I did was messing with potassium. I was extracting potassium from hardwood branches, right? And the compound would be, oh, actually, this is either potassium carbonate or potassium hydroxide. Those are my two guesses right now. I'm actually leaning towards the potassium hydroxide because of the chemical reaction that these underwent. So those are my two guesses right now, and we shall test the hypothesis, see if it's right. First thing I want to do is I want to test for carbonates, and that will require a lime water solution. So I've got some calcium hydroxide here. What we'll do is we will bubble the gas produced by this into a lime water solution. If it turns milky, that means there's carbonates present because of the carbon dioxide. So I guess if you have something similar and you want to know how to figure out what your crystals are, this could work for you as well. So if you pay attention and you follow through, you'll probably get to some decent conclusion. So a bit of a change of plans, though. What I'll do is I'll need a funnel. My funnel's dirty. I'm gonna go clean it real quick. Okay, funnel's all nice and clean. We don't want any other variables to mess up our experiment. So the funnel goes in there. Pop the cap. And I have to pour this one-handed. I should actually, you know what? I want to set up the camera right there. Okay, water's going in. I've already taken the crystals out, so I'm fine with adding the water in there to dissolve all the rest of that. Okay, glass stirring rod going in there. Make sure we dissolve a lot of those crystals out. I'm gonna make sure I get some of those on the side. As many as possible. Because I don't have that many, but we should have enough to run a couple tests. Okay, I'll pick you back up, and we'll put this on there. I'm going to use my automatic stir to stir this for me. This isn't necessary, but it's just handy, and what the heck, why not use it? Okay, that goes in. It'll automatically be stirring it for me. Okay, while that's stirring, I'm actually going to add a few more crystals to there. Just a couple more. Just to make sure. Actually, you know what? Let's run one test first. So I've got my pH paper here. I want to test the pH. You can turn that off. Test the pH. You usually want to actually not put the pH paper in there, and you would instead want to take some of it out and put it on the pH paper so it doesn't contaminate the solution. But it's not that big of a deal. So I should be using my tripod right now, but it's fine. I'm going to stick it like that. I'm going to tip this. And, okay. There we go. There it is. According to the pH, about a pH level of, I'd say 9. I'd say 9. I don't know what the typical pH of a potassium carbonate solution is, so I'm going to quickly Google. According to this, the pH of potassium carbonate is about 11.5. pH of potassium hydroxide is about 14. So that is that. So we do not have a pH of 14. We don't have a pH of 11. But we also don't have a pH of 14. So it's more likely going to be potassium carbonate. But still, I want to run more tests because that isn't actually the pH. So I'm going to add more of these. Quite a bit more of these. Into here. Just like so, not all of them. Still want a few left. I'll run the stir bar. Got that all dissolved. There it goes. And we will test pH again once that is through. Meantime, I want to set up my bubbler system. So here's what we're going to do. We're going to attach this stopper, and that'll go into this elbow joint. I'll have to grease that up first. I don't want to put that in completely yet. And then that will go into probably this one. Oh, actually, I want another elbow. There we go. Here's a second elbow, and that'll work just fine. Okay. Looks like it all dissolved just fine. I'm gonna stick the pH paper in again, and we'll see what we got. The other side this time. Oh, look at that. That is a bit darker, isn't it? You know what? That looks pretty close. That's like a 10 or 11. And according to Google, 11.5. So honestly, My guess, my money is on potassium carbonate right now. So my initial hypothesis, actually. So that is interesting. We'll keep that in mind, but I still want to perform a lime water test to make sure we have carbonates present. If the lime water test is positive, that means we definitely have carbonates, which I'm guessing is potassium carbonate. So far so good. Okay, so I'm going to set up the apparatus real quick, and I will let you know when I am done. Alright, the apparatus is now set up, so here is what's going to happen. Here's the chemistry. So we've got our solution in there, right? Which I'm assuming is a carbonate, more specifically, most likely potassium carbonate. What we'll do is we're going to add an acid. Today we're going to be using sulfuric acid, and we're going to pour that into the solution. What's going to happen is, if there is a carbonate present, the acid will react with it to form carbon dioxide. The carbon dioxide will travel up there, up that tube, and down into here. This graduated cylinder, which I set on top of this mortar, is going to contain what's called lime water solution. And all that is calcium hydroxide in a solution of water. I'm using distilled water as always. What will happen is, if there is carbon dioxide present, it'll actually turn the lime water solution from clear into a milky color. So that is the plan. So, yep, that is fine. If that does not happen, then we could have a hydroxide, but I highly doubt it. Yeah. I do have more tests if this doesn't work, so that'll be just fine. Okay, so now let's get into it. Okay, that's what it looks like. As you'll notice, I'm wearing gloves now. I'm actually also wearing goggles. It's not really that necessary, but it's good practice, so why not? Alright, so now I'm going to put this here. That's my graduated cylinder. And I'm going to take my calcium, what is this, calcium hydroxide? Yep, calcium hydroxide. I'm going to put a little bit of this. Whoa, that's a lot. I'll put a little bit of this. Oh, I'm spilling it everywhere, crap. Into the graduated cylinder. Just like so, put a little bit more. Just like so. Okay, don't do what I just did. Note to self, check solubility charts before starting. Apparently, according to Google at least, the solubility of calcium hydroxide is 1.5 grams per liter at, I believe, 20 degrees centigrade. So that's why it looks like that. It's hardly dissolved. Yeah, don't do what I just did. I can actually save this for later, but I got this, which at least should contain, calcium hydroxide. And to make sure, I can do a quick pH test. I believe it should be about 12. The pH should be. So there you go. There's that, and that's about it should be about 12.4, I think. And that is about between 12 and 13. So, yep. So we do have the solution all ready to go. This beaker I'll set aside. I'll put my Erlenmeyer flask back on. And here's our lime water solution. I'm going to carefully set this on top of my mortar. Just like that. So I think I already explained this apparatus before, so let's just get straight into the chemistry. Now, I am working with sulfuric acid here, so I'm going to have to be very careful. Stirring. Oh, I don't want to tip this over. I should use a better base than that, shouldn't I? These gloves probably wouldn't work that well for that. You know what? I'm going to be smart, and I'm going to replace this very unstable mortar with the bottom, with this little piece of wood here. That should be way more stable. Okay. Now back to what we were doing. It's always better to be safe than sorry when doing chemistry. Okay, so especially when working with strong acids. Alright. What I'll do is I will now pour the acid in here. Actually, I'll get that stirring again. In the middle. Pour the acid in. Just like so, and cap. Just like so. Okay, we are producing a gas. We are producing a gas. I don't know if you can tell that bubble is moving down. We are producing a gas. I shouldn't have used that long of a tube, but it should be fine. Should be fine. It's going down just fine. There it is. Make sure that's capped properly. Yep. Note to self, do not use this long of a tube. I actually think it is getting slightly milkier. I don't know if you can tell, but just in case, I'm going to perform another test, which you may have heard of before. Which what I'm going to do is I'm going to light this on fire, and I'll stick this above there. If it is carbon dioxide that's being formed and not some other gas, it should put this out. Okay. Hopefully you can see alright. Dang. Yeah, hopefully you can see alright. I'll put you over here, actually. Okay, here we go. We are still producing gas. I'm gonna light this. Actually, no. Let's see. Here. Okay, that's lit on fire. Just like that. Do that there. Pop this. See what happens. Oh, that's wonderful. Look at that. Stick that in a little bit further. I don't want to put it in the solution, and it just went out. It just went out. Which means, ladies and gentlemen, that is good old classic carbon dioxide. Ha ha ha. So that basically confirms my hypothesis. We do have a carbonate here, which means that this is most likely potassium carbonate. That is what I was after before, and I didn't realize that crystals were being produced in my flask before. I didn't even realize. But, because I thought I basically failed the last, but I didn't. There you go. Potassium carbonate crystals. Haha. So that confirmed my hypothesis. We do have carbonate crystals, most likely.
So far in this unit, we've been studying chemical reactivity. And now we're going to use that information to identify these 4 white powder samples using several different laboratory tests. Now, these powders may all look the same, but they're all different chemicals. Let's see if our students can figure out how to tell them apart.
In front of you are the 4 samples. You also have a solubility table and a stack of index cards. And on the index cards, I've written a different chemical test that you can use to learn about each unknown. The unknown powder samples are lead 2 nitrate, potassium iodide, calcium carbonate, and sodium carbonate. Your first goal is to identify which one is which. Your second goal is going to be identify the unknowns in as few steps as possible. So I'd like you to work together in your group and develop a plan, but check with me before you begin.
Let's look at the different tests and figure out what they can tell us.
All right, the first test is a solubility test, so we'll need the solubility table.
Okay, let's look up the solubility of the unknowns. Calcium carbonate is the only insoluble unknown.
The next test uses sodium chloride to identify lead. How does it do that?
Looking at the solubility table, lead chloride is insoluble. But other chloride compounds, like the sodium chloride we have, are soluble.
The next test uses hydrochloric acid to react with carbonate and form carbon dioxide.
How will we know if carbon dioxide's formed? Isn't it a clear gas?
Yeah, but the gases will make bubbles in the solution. But wouldn't the hydrochloric acid test also work like the chloride test to show lead?
I think you're right. We'll need to watch out for that.
The last test uses lead 2 nitrate. Isn't lead 2 nitrate one of our 4 powder samples? How does that help us?
Well, it sure is one of our powder samples, but maybe it does something with the other unknowns.
I looked at the solubility of lead. Lead 2 iodide is insoluble, so This test will help us figure out which unknown is potassium iodide.
I sort of get how we can use these tests, but how can we figure out what order to do them in?
Okay, guys, now that I've approved of your procedure, you can go ahead and begin.
Is that right?
Yeah.
Okay.
It's kind of hard to use the back of a spoon.
That's okay, it works.
We have bubbles.
Do you want
Did
to
you
do the
see that?
HCl?
Let's just do one at a time, I think.
That one dissolved.
Yeah, that one definitely dissolved. That's the